Welcome to our first video on deep space thinking. Everyone has heard of what a non-Newtonian fluid is, but the way it functions has barely ever, if at all, been explained. In this video, you will learn exactly this.
A non-Newtonian fluid is a type of fluid that does not obey Newton's law of viscosity. Now you may be wondering what viscosity even is. Viscosity refers to the resistance to flow of a fluid, meaning how easily it can flow. For example, water has a low viscosity when compared to honey, as honey does not flow as easily as water does. To explain Newton's law of viscosity, two key terms must be understood. First, shear stress is the force required to physically deform a substance, and second, shear rate of a fluid is the rate at which this deformation happens. Using these key terms, Newton's law of viscosity could easily be understood. His law describes the relationship between the shear stress and shear rate of a fluid subjected to a mechanical stress. In other words, it defines the relationship between the force required to deform an object and the rate at which it will deform when there is some kind of strain acting on the fluid. For example, the relationship between shear stress and shear rate of mercury is directly proportional, whereas quicksand has an exponential relationship. So if a fluid obeys Newton's law of viscosity, it will maintain its viscosity even if there is a force acting on it. Whereas, if it does not obey Newton's law of viscosity, its viscosity changes as different amounts of force acts on it. Following this understanding of viscosity, a non-Newtonian fluid can be defined as a fluid whose viscosity changes as strain or a force is applied on it. On one hand, a substance can become more viscous, nearly solid, and on the other hand, another substance could become less viscous. An example of a non-Newtonian fluid that can be made from household items is Oobleck. It is made from nothing more than cornstarch and water. If you were to try this at home, use a ratio of roughly 2:1 for amount of cornstarch to water. Here, we poured exactly 1 cup of cornstarch followed by half a cup of water. Then, we thoroughly mixed it until it achieved a thick and goopy consistency. So how does a plain mixture of cornstarch and water exhibit such non-intuitive and mysterious properties? Molecules of water are much smaller than molecules of cornstarch, Here, the red dots are the cornstarch molecules and the blue represent the water molecules. If there are more water molecules, the cornstarch has more space to move around when a force is applied, so they can slide past each other easily. As more cornstarch is added, the number of large molecules in the solution will increase, taking up more space until the space between the molecules is smaller than the size of the molecules. Thus, there will be less space for them to move around. Therefore, when a sudden force is applied on Oobleck, the molecules are compressed as they bump into each other. This causes it to behave like a solid. On the other hand, if pressure is applied over time, the molecules have time to move around each other, thus behaving like a liquid.
Thank you everyone for watching, and we hope you enjoyed the video. If you did, please consider leaving a like, subscribing for future content, and commenting below regarding this video or what we should do next. Thank you.